Friends, this is part 2D of 2023 questions of AP1. So now the previous part we have done, this is 2D. The student wants to confirm that the acceleration is the same whether the cart is rolling up or down, right? The student starts the cart at the bottom. The student starts the cart at the bottom and gives the cart a quick push upwards so that it is going upwards momentarily comes to rest. X-axis still defined to be parallel to the ram with the origin at the third. So this is the origin and this direction, this is the positive X direction as shown here, right? The acceleration of the cart is the same whether the cart is rolling down, it's not rolling, is coming down, or whether you push it up with some speed and it goes up. In both the cases, the acceleration is the same. There is no friction, there is no air resistance, is what we are assuming. In both the cases, the acceleration is due to gravity, okay, a component of gravity actually, because the acceleration is in this direction. So a component of gravity is actually acting in that direction, okay. So it doesn't change. The acceleration due to gravity along the ramp downwards is the same, no matter the cart is going upwards or downwards. So on the following graph, sketch the position x and velocity v as a function of time that corresponds to the scenario shown while the cart moves up the ramp. So now what the student is doing to ascertain that, he pushes the cart upwards. He throws the cart upwards with some velocity. Let's say u naught. Let's say u naught is the velocity with which the student is throwing the cart upwards. So what happens with the cart? It moves up the incline somewhat and then it stops. Then it stops. So again, the acceleration is going to be in the same direction as before. The acceleration was down the incline like this. It's still the same. So if I have to make the graph of position and time and velocity and time for this situation here, when the cart is being pushed upward. So I know the displacement formula, S is the displacement, is ut plus half a t square. This is the formula we know for displacement when the acceleration is constant. Starting from this position, first let's write the expression to get the displacement. Initial velocity is u naught. But remember, this is the positive direction. This direction is the positive. So this direction is the negative direction as per our convention. I have taken the displacement starting from this point here. This point here is, let's say, x naught. This position here is x naught. X naught is some positive x value, because this is what I have called 0 and this direction is positive. So let's say the position here right now is x naught. So the displacement is going to be u, initial velocity is negative u naught, it is being thrown upwards, times t plus half, acceleration is a, positive in this direction, and t square. So this expression here is the displacement. So if I have to find the position, I add the initial position. So initial position was x naught and this has been the displacement. So initial position plus the displacement gives you the position at any given time t. So this is the expression. This is the position at any given time t, given the cart has started from a position x naught and is being thrown upwards with a speed u naught, right? So basically I have to make the plot of this one for this graph here, x versus t. Now you see this is a parabolic graph. The coefficient of t square is positive. So the graph, the parabola will be opening upwards. So at t is equal to 0, if you put t is equal to 0, the value is x naught here, where it started off from. Position is x naught, right? It is going to be a parabola. X naught is decreasing with time, right? Sorry, x is decreasing with time. It is going towards the x is equal to 0 point. It is traveling upwards, right? Up the incline. So the graph will be parabolic, opening upwards and like this. It will be, maybe it is not able to reach up to this same point x is equal to 0. Maybe it comes and stops here. Okay. So wherever it stops, this point corresponds to where it stops finally. Okay. X final, if I mark this, if this position is x final where it stops. Right. Next, I have to make a graph of velocity. Again, the equation of motion is v is equal to u plus at. This is the equation we have. For this situation, I have to find the final velocity. Final velocity is, initial velocity is u naught in the negative direction. Negative u naught. Acceleration is positive and this is t. So this is what I have to plot here. This is a straight line. Okay. For, in terms of t, this is straight line. A is positive, so the slope is positive. And at time t is equal to 0, it has to start from here, because so this is negative u naught, this mark. Okay. This is a straight line and will be a graph like this. At this point, the velocity is 0 and the cart comes to a rest. Corresponding to this point, the velocity is 0 and this is the point actually at the position xf, the velocity has become 0. So this becomes the graph of v and t for this block that has been pushed upwards with some initial velocity. And this here gives you the position versus time graph. Okay. So this explanation is sufficient to give for this question here. Okay. Thank you.